Hello everyone, I'm RK. Welcome to Khan's Chemistry online channel. Aldol condensation is one of the important named reactions from carbonyl compounds in organic chemistry. The word aldol is derived from the combination of aldehyde and alcohol. Ald from aldehyde, OL from alcohol joined together as aldol because the product formed will have both the functional groups aldehyde group and alcohol group, both are present in one single compound. Therefore those compounds are called aldols because they possess both the properties like aldehyde and alcohol. When these aldol undergo further condensation on heating, it forms alpha beta unsaturated compounds, alpha beta unsaturated carbonyl compounds. We know carbonyl group is a functional group which has both aldehydes and ketones. When C double bond O group when C double bond O group has one hydrogen on one side and any alkyl group on the other side, we call it as aldehyde. Similarly, C double bond O group, when attached to two alkyl groups, we call it as ketones. Both come under carbonyl compounds, carbonyl group. So, aldehydes, when they undergo aldol condensation, they form aldol. Ketones, when they undergo aldol condensation, they form ketol. Both aldehydes and ketones, when they undergo aldol condensation, commonly we can call it as aldols, though it is a ketone. Condensation Condensation reactions are when two or more molecules combine together to form a large molecule with the loss of small molecule like water molecule or hydrogen gas or ammonia gas will be lost when two molecules combine together. With this loss of small molecule, a large molecule is formed. Those type of compounds are called condensation compounds. Compounds formed by condensation reactions. So, when aldehydes or ketones undergo aldol condensation reaction, aldol products are formed. Aldol products are formed. When these aldol undergo further condensation, they form alpha beta unsaturated carbonyl compounds. Why? Because the carbon atom which is first attached to the functional group. Here C double bond O is the functional group. This is one alkyl group like R, and this whole part is one alkyl group. The carbon atom which is directly attached to C double bond O group here, that is alpha carbon. The next carbon, second carbon which is attached to alpha carbon and alpha carbon is attached to C double bond O, we call it as beta carbon. Similarly here C double bond OH, aldehyde functional group. The first carbon atom which is directly attached to C double bond OH, aldehyde. The first carbon atom which is directly attached to CHO group is alpha carbon. The next carbon, second carbon which is attached to alpha carbon is beta carbon. In this case, this whole group is one alkyl group. and one side hydrogen is attached to C double bond O. Therefore, it is a aldehyde. Here CH3 is one alkyl group. This whole part is one alkyl group. Two alkyl groups are attached to C double bond O, which is a ketone. So when aldehydes undergo aldol condensation, it form aldol. When ketones undergo aldol condensation, it form ketone. Both generally we can call it as aldol. When this aldol product undergo condensation on further heating, they form alpha beta unsaturated aldehyde or ketone, because on further heating, one hydrogen from alpha carbon and OH group from beta carbon, they lose as water molecule. That is what condensation, right? With the loss of small molecule, a large molecule is formed. When this aldol product undergo further condensation, hydrogen from CH2, which is a alpha carbon, hydrogen from this carbon and OH group from this carbon leave out as water molecule. Therefore, double bond is formed between alpha carbon and beta carbon. Hence, it gives alpha beta unsaturated aldehyde. Aldol condensation is a chemical reaction in which two or more molecules of same or different carbonyl compounds containing alpha hydrogen atom unite together in the presence of dilute base to form compounds called aldols. This is the definition of aldol condensation. It is a chemical reaction. Two or more molecules of same or different carbonyl compounds. Like in this example, we can see two molecules of aldehyde, acetaldehyde, are involved in the reaction. We can take either same aldehydes of two molecules, or we can take one acetaldehyde with some other aldehyde. Either same carbonyl compounds we can take, or different carbonyl compounds also we can take. The only condition is it should contain alpha hydrogen, which means this is the functional group. C double bond OH, CHO is the functional group. The first carbon atom, which is directly attached to the functional group, should have at least one hydrogen on it. The alpha carbon should have hydrogen on it. This hydrogen will be called as alpha hydrogen. So you can take either same molecules of aldehydes or same molecules of ketones, or two different aldehydes or two different ketones, or combination of aldehyde and ketone. Any two carbonyl compounds can be involved in aldol condensation. The only condition is it should have alpha hydrogen atom. The compound should have alpha hydrogen atom on the alpha carbon. Therefore, these two compounds, they combine together in presence of dilute base. We can take sodium hydroxide, dilute sodium hydroxide, or dilute barium hydroxide, or potassium carbonate, any base. In presence of dilute base, it form aldol product. These two reactions are same. Two acetaldehyde on aldol condensation give aldol. When this aldol undergo further heating, it loses water molecule to form alpha beta unsaturated aldehyde. Here it is a but2-enol. Alpha beta unsaturated aldehyde. So this is the example. Instead of explaining with general reaction, directly I am explaining with acetaldehyde reaction, acetaldehyde example, so that we can understand the mechanism easily. So when two molecules of aldehydes undergo aldol condensation in presence of dilute base, it forms aldols. This aldol, when it undergo further heating, it loses water molecule, hydrogen from alpha carbon, OH from beta carbon will be lost as water molecule, so that double bond formed between alpha and beta, it forms a alpha beta unsaturated aldehyde. Let's see the mechanism of aldol condensation step by step. In the first step, OH negative hydroxyl ion attracts proton H positive from first molecule of acetaldehyde. In presence of dilute base, this hydrogen acts as a acidic hydrogen. This carbon can leave this hydrogen easily as H positive. It acts as a acidic nature. So this hydrogen is attracted as H positive by this hydroxyl ion, so that this hydrogen leaves its electron to carbon. In the next step, it gains negative charge on it, and H positive comes out as water molecule along with hydroxyl ion. In the next step, water molecule is separated as H positive combines with OH negative, and the electron left over to the carbon possesses negative charge on CH2. We call it as enolate ion because if you look at the resonance structure of this enolate ion, this is the structure. CH2 contains negative charge on it, which is attached to a aldehyde group. When this negative charge is shifted towards this carbon, it forms double bond. CH2 forms double bond with C double bond O. As this carbon already have 4 bonds around it, oxygen will take the paired electron towards it. Therefore, oxygen possesses negative charge in the next step, and double bond is formed between these two carbons. That is the enolate resonance structure here. Double bond. When double bond is present, we call it as ene, and this O negative can attract H positive to form OH here, right? Which is a OL, alcohol. So ene plus alcohol, enol. Because it is in the form of ionic form, we call it as enolate ion. Either H positive can be attracted here, or any metal with positive charge can be attracted here. So this is the enolate ion. And this is exactly the resonance structure of this enolate ion. These two forms we can call it as enolate ion. So in the first step of mechanism, hydroxyl ion from dilute base attracts H positive ion from acetaldehyde, so that deprotonation, proton means H positive, because OH negative is separating H positive, we can call this as a deprotonation, so that enolate ion is formed in the first step by deprotonation. The enolate ion formed in the first step combines with the second molecule of acetaldehyde in the second step, so that when it shifts its lone pair of electron towards this carbon to form a new carbon-carbon linkage, the bond pair of electrons between carbon and oxygen shift towards oxygen, so that in the next stage oxygen gets negative charge on it, and this enolate ion is joined with this acetaldehyde in the product. So it forms a alkoxide ion in the Second step. The alkoxide ion combines with water molecule so that H positive from water molecule combines with O negative in alkoxide ion to form aldol product so that hydroxyl ion is separated. Therefore, aldol product is formed. In the first step, deprotonation taken place and enolate ion is formed. And in the second step, nucleophilic, this is a nucleophile, negatively charged group, right? Nucleophile is added to the acetaldehyde. So nucleophilic addition taken place to form alkoxide ion. This alkoxide ion when combines with water molecule, it attracts H positive from water molecule as O negative is here. It forms a alcohol. Finally, it forms aldol product by separating hydroxyl ion in the third step. After formation of aldol product in the third step, when we heat it further, the hydroxyl ion attracts H positive from aldol compound because always alpha hydrogen in this group acts as acidic, more willing to come out as H positive. Alpha hydrogen is more acidic in the compound, so that OH negative ion attracts H positive to form water molecule, and again a negative charge is formed on the alpha carbon when we heat it further. Again this negative charge, when it shifts towards the beta carbon, OH negative OH group present on beta carbon leave out as OH negative hydroxyl ion, so that single bond turns into double bond with new bond formation here, which is alpha beta unsaturated aldehyde, right? Hydroxyl ion is separated. First, OH negative hydroxyl ion removes proton H positive, and then in the next step, because of formation of double bond instead of single bond, when it forms alpha beta unsaturation, it leaves OH negative from the beta hydroxy aldehyde or aldol. It leaves hydroxyl group as OH negative. Finally, alpha beta unsaturated aldehyde is formed. This is another reaction with ketone. CH3 C double bond O CH3, which is a C double bond O group with two alkyl groups, is a ketone. Two molecules of ketone can undergo aldol condensation to form beta hydroxy ketone. C double bond O group directly attached to alpha carbon, and then second carbon which is attached to alpha carbon, beta carbon. On beta carbon, OH group, hydroxy group is present. So beta hydroxy ketone. When also we can call it as ketol. When this ketol undergo further heating, then alpha beta hydrogen from alpha carbon, OH group from beta carbon can leave out as water molecule, so that double bond is formed between these two carbons. Alpha beta unsaturated ketone. This is another example with ketones, and this is the general reaction for aldol condensation. C double bond O group attached to alkyl group, and that alkyl group consists of hydrogen, two hydrogens, and R dash, R double dash, R triple dash can be hydrogen or any substituent with carbon, any alkyl group or hydrogen. So C double bond O group carbonyl compound combined with another carbonyl compound. Can be two aldehydes, can be two ketones, can be aldehyde with ketone. When two carbonyl compounds combine together in presence of dilute base, it forms alpha beta unsaturated carbonyl compound by leaving water molecule. This is the general reaction. That's all for the day, viewers. We'll get back to you with another video on chemistry. Thanks for watching this video.